right, so here's problem number 9 from 9.5. So we're asked to find out whether this is convergent or divergent, and we're not told which test to use. What test would you like to use? You could do the integral test? No, that's what they suggest, and I think it's a good suggestion. Now remember, for the integral test, what we're going to say is there is an integral of a function that looks like natural log n over n, and that function would be natural log of x over x, and what we'll want to do is go from 2 to infinity dx. Now there's a couple other conditions that we should make sure. Is natural log of x over x always positive? Natural log can be negative sometimes, but this is true as long as x is greater than 3. Actually, it's greater than e. So it's eventually true, and that's actually good enough. Okay. The other thing is natural x over x decreasing? Is this function decreasing? That's the other condition that we have to have for the integral test. Is it clear that it's decreasing?
It has to be decreasing.
It has to be a function that's decreasing at least from some point and then the rest of the way. To answer the question if it's decreasing, we could look at its first derivative. The derivative of this is bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. This ends up being 1 minus the natural log of x over x squared. Well, the bottom is always positive, and the top will be negative as long as the natural log of x is big enough. And it's big enough when x is greater than e. So this is decreasing when x is greater than e. So it's eventually decreasing always. Eventually it's positive always. We meet those conditions. Let's go to this part. Let's go back to the integral and say, well, is the integral finite or is the integral infinite? Oh, rewrite. Limit. Oh, I've temporarily forgotten what to write here. Very good. The integral from 2 to b of natural log x over x dx. I think this is going to be a u substitution. Natural log of x is a great choice. 1 over x dx, and here's 1 over x dx. That's great. So we get the limit as b goes to infinity of the integral of u du, and we're going to need to go from natural log of 2 to the natural log of b. Is that okay? All right. So we've got the limit as b goes to infinity of the natural log of, sorry, I got to take the antiderivative of u. 1/2 u squared evaluated from natural log of 2 to natural log of b, which is equal to the limit. So excited I can't write. B goes to infinity of 1/2 natural log of b squared minus 1/2 natural log of 2 squared. Now let's ask ourselves the question, what happens when b goes to infinity? B goes to infinity, natural log of b goes to infinity. Infinity squared is infinity. So I got a big old infinity coming out of this area. What do I got here? I don't know what it is, but it's finite. That integral diverges. I'm ready for my conclusion. Therefore, that thing. Can you be less specific?
Whatever.
the series from n equal 2 to infinity of natural log of n over n diverges by integral test. Now, I'm not going to do this. I'll do this again, but I do want you to note that this thing looks a little bit like 1 over n, except it's bigger than 1 over n. It kind of looks like 1 over n, but natural log of n is bigger than 1 for n's that are bigger than 3 or larger. You could have done something called, you could have done the direct comparison test. This series is a known divergent series, and this thing is bigger than that. So you could have done it that way as well. I like the integral test for this one better. All right, that concludes number 9. Any questions? Nope? Okay, number 9 done.